Yeah, hello, and welcome back in our class of soil mechanics. We are going to try to make progress. We are still on this chapter 5, which is about classification of soil. Okay, so I think last time we talked about this classification, a store classification system. In this video, we will talk about unified soil classification system, which is a very widely used system of classification, originally developed in USA. Okay, so sorry here, not this one. The point number 5, unified soil classification system. So before we start, I would like to remind you some little things we did before previously, mainly in chapter 2. Okay, because these things are some information we need. I need you to understand this information before we proceed to the unified classification system, okay? This is among these things we have here, plastic limit and liquid limit. I need you to remember that. What is plastic limit? What is liquid limit, okay? Liquid limit. This is the chapter number 2, I think, okay? Or chapter number 4. Maybe chapter 4, yes. Chapter number 4. We have talked about what is liquid limit and how we can estimate liquid limit, okay? And this is the formula for estimation of liquid limit. So liquid limit is the amount of water. First of all, it's amount of water, okay? Amount of water which you need to mix with the soil so that the soil, the border between the liquid state of soil and like here, the border between the liquid state and the plastic state of soil, okay? This is liquid limit. And this is how we determine it. This is how we obtain it from this formula, depending of number of blow, okay? And another thing we talked about is plastic limit. And here is how we obtain it. Plastic limit is then the amount of water that is in the border between the plastic state and the semi-solid state of soil, okay? The amount of water you need to put to obtain this border is the plastic limit, okay? And what is now the plasticity index, PI? This PI is just liquid limit minus plastic limit, okay? Sorry, all this information, I hope you know already. If you don't know, I advise you to go back and check chapter number 4, okay? Yeah. Another thing we need in this classification system, before we go to the unified classification system, is about sieve analysis, okay? Maybe you remember this. This is in chapter number 2. This chapter number 2, we talk about sieve analysis, mechanical analysis of soil, and I need you to remember this information, that sieve number 4, the opening corresponds to opening 4.75 millimeters, okay? And this one, sieve number 200, correspond to the opening 0.075 millimeter, okay? So this is what I need you to remember. And we have talked about this also in chapter number 2, still in chapter number 2. And this is the classification we will talk about here in this video. Our main topic today is this, okay? What is how to classify the soil following this unified soil classification system. So that's why I need you to remember what this system is telling us about the different type of soil, about definition of type of soil. Okay, so this system is saying that between 76.2 to 4.75 millimeter, the soil is considered as gravel. Okay, 4.75 to 0.075, this is sand, dimension of sand in millimeters. Okay, and when the soil has particle less than 0.075 millimeter, the soil is considered as fine soil, which means silt or clay. This is just a reminder, okay? So I'm going to link the previous sieve number and this table. These are this is the table for the sieve number, okay? You remember I told you to keep in mind this sieve number 4, which correspond to 4.75 millimeter. So this will correspond directly to this one, okay? So the lower limit of this gravel. So it means we can link these two. So if something doesn't pass this sieve number 4, it means if a soil or soil particle doesn't pass this sieve number 4, it means it is gravel, okay? So we need to know what is the amount of soil that is retained in the sieve number 4. That will be gravel. Because if it doesn't pass the sieve number 4, it means that the diameter of the soil, that soil particle is larger than 4.7 to 75. Okay? Because the opening of this sieve is 4.75. So if any soil particle doesn't pass this sieve, it means that that soil particle has diameter higher than 4.75. Then that soil particle is gravel. Okay, so we need to know what is amount of soil percentage retained on this sieve. This is one. Okay, and we need to know also this sieve number 200, which correspond to this, the lower border of the lower limit of this interval, means 0.075. Okay, so if something passes this sieve 200, the sieve number 200, if any soil particle passes this sieve number, it means that that soil particle has a diameter smaller than 0.075, which means that that soil particle is silt or clay particle. Fine. Okay. However, if the soil particle doesn't pass the sieve 200, that means it passes the C4, okay? Obviously, it has passed all these numbers and it comes here and doesn't pass sieve number 200. That means the particle has a diameter higher than 0.075. Okay? So we suppose that the particle has passed the sieve number 4, okay? Past sieve number 4 means the diameter is smaller than 4.75. However, it doesn't pass sieve number 200. It means the diameter is then smaller than, higher than 0.075 millimeters. Okay, I repeat again. If the particle passes the sieve number 4, then the particle will go through all these sieves numbers up to here. If the particle doesn't pass this sieve 200, number 200, that means the particle has a diameter higher than 0.075. But since it has passed the sieve number 4, it means the diameter is smaller than 4.75. In that case, that particle is considered as sand particle. Okay? So that means we need to know what is retained on the sieve number 4. That part will be gravel. What percentage is retained? That is one. We need also to know what is the amount passing the same sieve number 4. Okay? And after that, we need to know what is retained on the sieve number 200. And we need to know what is passing, the percentage of soil passing the sieve number 200. So mainly, we need information of these two sieves. Sieve number 4, sieve number 200. And mainly, I want you to remember about the sieve number 200. That one is the first one we will attack if you want to classify soil using the unified classification system, The sieve number 200. Please remember that. The sieve number 200. Remember that if 50% of soil passes the sieve number 200, the soil will be considered as fine soil. And if 50% of the soil doesn't pass sieve number 200, then the soil is coarse-grained soil. Technically, after this video, this part of this chapter is over. All this chapter is around this point, this sieve number 200. That's why I am spending more time on this. If 50% of the soil passes this sieve number, means the soil is fine. Okay. If on the contrary, 50% doesn't pass, the retained amount on this sieve is more than 50% of the soil, then the soil is not fine soil, it a coarse-grained soil. That's what you need to remember. Mainly this one. Okay. Okay, let's proceed. Another thing I want to remind you is about the grading of soil. You remember what is poorly graded soil and well-graded soil? The curve number 1, for example, this one, is poorly graded soil because this soil has almost same size same particle size. Okay. On the other hand, well-graded soil is a soil that has various soil particle diameters. You see this curve, it covers many particle diameters. You see here, particle diameters in millimeter. It covers from maybe here up to here. So it expanding. Okay, that is what we are calling well-graded soil. However, if the soil doesn't have many size, a lot of sizes are missing. For example, for this soil, number 1, okay, I hope you remember this graph. Okay, remember this graph, particle size distribution curve. So if this particle size distribution curve is almost vertical, then the soil is poorly graded soil. That's the meaning. So I need you to remember that also. We will just use the name. Okay. So now we can start the classification system. Now we can start. Unified soil classification system. What can we say about this? So we can say that this system was originally developed, proposed by Casagrande. Casagrande proposed the system in 1942. That was during the Second World War. And it was developed for the airfield construction, for the airplane. Okay. And as you can see, US Army Corps of Engineers. And then after that, they revised the system in 1952, I think. And now this classification is widely used in almost in all countries, I think. And the designation of this system is this designation, American Society for Testing and Material, test designation D2487. Okay. This is just information, okay? So this system, this unified classification system is presented in this table. As you can see the table. And the table has two categories. We can see two categories here. Two categories, okay? The first one is this one. Coarse-grained soil. Do you remember the sieve number 200? I just told you about it. And I told you I need you to remember. Okay? If more than 50% of the soil is retained on this sieve 200, more than 50%, then we will have coarse-grained soil. It means the soil will be like sand or gravel. Okay? More than 50. Do you understand this English? More than 50. If it equal 50, it will not be here. More than 50, it need to be higher than 50. 50.1, 55, it's okay. But 50.00, it is not here. It's very clear, more than 50%. The sieve number 200. I don't want to go back again because I already explained this. What is the sieve number 200 and the reason why I explained this before starting is here. Okay. And then The second part of this system classification is here. Fine-grained soil means like clay and silt. This is when 50% or more passes the sieve number 200. It means if it is 50, you are here. 50.00, you are here. Okay? Here is higher than 50. Is strictly higher than 50. Here is 50 and more. This is retain. Do you understand? Retain. And here is pass. Don't be confused. Retain. You have the sieve number 200. If 50% or more than 50% is retained, means didn't pass, then you are dealing with coarse. Okay, it has to be more than 50 that is retained. It means again less than 50 passes. Because if more than 50 is retained, it means less than 50 is passing, right? And here for the fine grain, it reversed. Now, more than 50 is passing. That means less than 50 is retained. Because if you see the sieves, you put the soil on the top, the first top sieve, and shaking. After shaking, the soil is passing through the sieves. Okay? So just remember this, very important. So what we are going to do next is we will take one by one of these and try to dig deeper in this to show you how you classify the soil. Okay, so I'm going to start with the first one. You see the color red, this red one, and after that the green one. So let's go with the red one. Okay, red one means, and did I talk about red one means more than 50% is retained on the sieve number 200. Okay, in that case, the soil is coarse-grained soil. That means the soil is gravel or sand. Two choices you have. Now, how do you determine, how will you know if the soil is sand or gravel? In that case, you will need to go to sieve number 4. You remember I talked also about the sieve number 4 in the introduction of this video. So if more than 50 is retained on the sieve number 4, it means you are dealing with gravel. But if 50 or more is passing, then you are dealing with sand. So it means we use the sieve number 200 to separate coarse-grained soil and fine-grained soil. This is first step. And if you have coarse-grained soil, you have to separate if it is sand and or gravel. To do that, you need the result of sieve number 4. If more than 50 is retained, then you have coarse-grained soil. You have gravel in this sieve number 4. But if more than 50 is 50 or more, even 50 or more is passing, this time not to retain, is passing the sieve number 4, then you have sand. Okay? And now, if you have sand or gravel, you need to know if this sand or this gravel, is it clean sand or it is mixed with some fine? Because sometimes you have sand mixed with some fine, some clay, for example, or sometimes gravel mixed with some fine, means clay uh, or silt sometimes. Okay, so you need to check these two. And how do you check? How do you know? How will you know if your sand or your gravel is clean or is mixed with fines? For that, it's simple. You go to check less than 50%, this A. If the amount of fine in the soil is between 5 to 12, you will have this double nomination. But if the fine in your soil, the percentage of fine, do you understand what is the meaning of percentage of fine? Fine means it's smaller, what is passing the sieve number 200. Because this classification I show 3 intervals: gravel, sand, and fine. If you remember the beginning of this video, the fine are what is passing the sieve number 200. If what is passing the sieve number 200, since we know that it's small, but how small it is it less than 5%? If it is less than 5%, then you will have clean gravel or clean sand, in case you have gravel or sand, depending on this. Okay, however, if it is more than 12%, the percentage of fine is more than 12%, in that case it is not clean sand or clean gravel. Okay, so less than 5%, it like you have this small interval for the fine, 5, 12. If it is less than 5, then you can say clean sand or clean gravel. But if it is more than 12, then you can say that this is gravel or sand mixed with some fine, means gravel and clay, for example, gravel and silt. Okay, to make it easy, let's consider this part first. So less than 5, between 5 to 12, we will explain later. But 5, 12, less than 5, it is clean sand. More than, let's say, gravel, we will deal with this first. If the amount of fine is less than 5%, then you are dealing with clean gravel. If the amount of fines in the soil is higher than 12%, then you are dealing with gravel mixed with some fine. Gravelly clay, for example, gravel with clay or gravel with silt. So consider that we are here, clean gravel. For you to get that, it's just the amount of the fine. However, your clean gravel, you will need to know if it is well graded or poorly graded. I just explained what is well graded and what is poorly graded. In the introduction, I explained this, what is the meaning of that, okay? So if you have, say the coefficient of uniformity, this coefficient and this coefficient, the coefficient of curvature, okay? These two coefficients, if you don't remember what it is, I recommend you check chapter maybe number 4 and chapter number 2. This to what is this coefficient of uniformity. This is how we calculate it. D60 divided by D10, D30 divided by these two. Okay. So if this is higher than 4, and this one is between 1 and 3, okay, the formula are here anyway. Then if these two conditions are respected, then you are dealing with well graded. The grade is well graded. Okay. Then you will have this symbol, group symbol. Okay. GW. You will have GW. G is standing for gravel. W is standing for well graded. Like this. W is well graded and P is for poorly graded. So as you can see, if you fall in this condition, CU, this coefficient is less than 4, and this one is respecting these two conditions, okay, less than 1 but higher than 3. In that case, your gravel is poorly graded gravel, okay, GP. Okay, same here for sand now. For sand, if you have maybe we continue with gravel, but gravel with fine. Here we talk about gravel, but without a clean gravel. Now gravel with some fine. If there are some fines, clay or silt in the gravel, in that case, what you need, and to know that you measure the amount. If it is more than 12%, then it means the amount of the fine is not negligible. So in that case, you will refer to the PI. Okay. Plasticity index, which is liquid limit minus plastic limit. I have explained this also in the introduction of this video. So if the PI is less than 4 or plots below the line A, this figure also, we have talked about this figure before. This, the x-axis, we have liquid limit, and the y-axis is plasticity index. Okay, so if you plot the you have the PI here, less than 4, it means you are here. If it is less than 4, around here, and it is below the line A. Line A is this line. Okay. Line A is this line. In that case, it means you have this M. GM. G means gravel. M means here silt. It means there are some silt mixed with your gravel. PI less than 1, less than 4, around here, and you fall below this line, not above this line, the line A. Okay, but if you have the PI, the plasticity index, higher than 7, 10 is here, higher than 7, and your liquid, when you plot a point considering the liquid limit, and you fall above this A line, it means maybe around here. Okay, if it is in this area, then you will have GC, means it is clay. Okay, C here is for clay, M here is for silt. So you do same thing for sand. Check if it is clean sand. For you to check that, you need to know the amount, the percentage of fine. Percentage of fine is the percentage passing the sieve number 200. If that percentage is less than 5, then your sand is clean sand. Then you go and check these two coefficients. If this condition is respected, then your sand is well-graded sand. Okay? But if you still have a clean sand, but these conditions are respected, coefficient of uniformity less than 6, the CC is less than 1, higher than 3, then you have poorly graded sand. Clean sand, but poorly graded. But now, if your sand is mixed with fine, it means in your sand, the amount of fine is not negligible. And for you to know that, you have to check the percentage of fine, the percentage of soil passing the sieve number 200, because the sieve number 200 is the one that everything passing that sieve is fine. The fine is small particles passing the sieve number 200. So if the percentage is higher than 12, then your sand is mixed with some fine. The amount of fine is not negligible. And for you that to know if it is silt or clay, you use the PI, plasticity index. So if the plasticity index is 4, less than 4, and you plot lower than this line, this is all, okay? This condition or this condition, okay? Then you have silt, sand SM, means sand mixed with silt. Check here, this one is PI higher than 7, and the problem is this one is all, but this one is N. This means these two conditions have to be respected. Otherwise, it will not be what we want. So PI higher than 7 and the plot on or above the line A, this line. So 7 and so it has to be around here. But the previous one is just it can be less than 4 or here below the line A. So anyway, in that case, you will have clay. Same as here also. Here is O and here is end. So these are the symbols we have. The problem now is when you have the percentage of fine means the percentage of soil passing the sieve number 200. When that percentage is between 5 and 12%. Here, 5 and 12%. In that case, you have to use double symbol this way. Because in that case, we don't know if it is for example, for the gravel, you have to use GW and GM or GWGC or GP. Means you have to mix these 4 combination of these 4 for gravel. Can be this one and this one, this one and this one, this one and this one, this one and this one. Okay, 8 possibility. For example, if you have these conditions are respected, the CU is higher of equal to 4 and the CC is between 1 and 3. This means you have this symbol. Okay, and then you don't know the amount, the percentage of fine is between 5 and 12. That means you have to check this one. If you fall here, this condition, PI less than 4, or you plot below the line A, in that case, you have this one. In that condition, you have to do these 2 combinations. Okay, that is the meaning. Okay, I think this is okay. Let's move to a small summary of what everything we said here. Just summarize. So the first, this is coarse-grained soil, and that are gravelly and sandy in nature, with less than 50% passing the sieve number 200. This is just what we have explained so far. So the group symbol start with the prefix G or S. G stands for gravel, S stands for sand. Okay, that's all for this part. Now let's talk about the second part of this chart. The green one. Maybe now this one we try to go faster. So this means the amount of soil passing the sieve number 200 is more than 50%. Is equal or more than 50%. The amount of soil passing the sieve number 200. Okay. In that case, your soil has to be considered as fine-grained soil. And in fine-grained soil, you have two possibilities: silt or clay. Okay, silt and clay. And after that, you go for the liquid limit. Where is the liquid limit? If your liquid limit is less than 50, or your liquid limit is more than 50 or more than 50, you are here. Two possibilities. This part, let's take this one first. Silt and clay. Liquid limit is less than 50. Look at this chart. You have a liquid limit here. You see this line? This is the limit of what we have here. This part is for this above two lines. Okay. This part, liquid limit 50 or higher than 50, is this one. So let's talk about this part first. Okay. So we have two possibilities: inorganic or organic. Organic means soil that contains some, I don't know, organic matters like grass or roots, okay, vegetation, something like that. So if you have the PI, plasticity index, higher than 7, and here is N, so it's two conditions, and you plot on or above the line A. So 7 is around here, and you are above line A. It means it has to be this area. Okay? In that case, what you have is CL. CL. C is for clay. L here is low plasticity. The L here is for low plasticity. It means clay with low plasticity. Okay? But if you have here PI is less than 4, or here is or you plot by doing the coordinate system, liquid limit and plasticity index, liquid limit, plasticity index, and you get a point that is below the line A here. Just make sure you don't go here, because this part is for this second part. Okay, I told you already. You have to stay here, this left of this part. Okay, so less than 4 is less than 4. It can be here or below this line, A line. So it means this corner. In that case, you have silt. The symbol of silt is M, and still L. L means low plasticity. So it means your soil will be silt, but with low plasticity. Okay. Now for organic, sometimes when soil has organic matter in it, this you have to try to know the amount of organic matter in the soil. So for that, you do liquid limit. When you dry, you oven dry the soil. If the soil contains some organic matter, it will affect the liquid limit of the soil by just oven drying the soil. Okay. So what you do is liquid limit oven dry divided by liquid limit not dried. Then if this ratio is less than 0.75, okay, then you will have the OL zone. Where is OL? OL zone is here. Here also is OL. The O here stand for organic. L means low plasticity. Yeah. I think everything here is low plasticity. The plasticity is low, not high. And now let's go to this one. When the liquid limit is more than 50, is higher than 50, in that case, we will be in this zone, in this area. Okay. In case of inorganic soil, you plot your, you use your PI, the plasticity index. If the plasticity index is, you plasticity index plot on or above the line A, this line A. Please remember that we don't consider this zone anymore. We are here. So here, okay? In that case, you will have CH. It means C is for clay, H is for here, high plasticity. Because as you can see, plasticity index, it is high. Everything here, it has high plasticity. Then you will have CH. Sorry. Now, if you have the PI plot below this line, you will have MH, means silt with high plasticity. This one. Okay. Then for the organic soil that contain organic matter, if you do limit liquid oven dried and above limit liquid not dried, and this give you something less than 0.75, it means the amount of organic matter in soil is not negligible. Then it has to be OH here or here. OH. Okay. It doesn't matter in that case where you plot here or you plot here, it will be OH. It means organic matter, organic soil with high plasticity. So this is how the fine grained soil are classified. So another thing is this one, peats. How do you classify peats? How do you know that soil is peat? Okay, this one. Peats are primary organic matter. If you take, I think at the beginning of this program, I have showed some picture of peats. It's just like some soil mixed with a lot of vegetation, roots, this kind of soil. So for this kind of soil, there is no you just, if you see, you know already. Just by seeing the soil, you know that this is peat already, okay? Because it has a lot of vegetation in it. Just the soil is just vegetation. So we call it peat. So primary organic matter, dark in color, and organic odor. It smells also. The smell also is something. So to summarize this, or summary, The second part of the classification is fine-grained soil. So 50% or more passing the sieve number 200. Okay. And the symbol we have is M for silt, with which stand for organic silt, inorganic silt. If only M, it means inorganic silt. C is for clay, inorganic clay. O is for organic silt or clay. And this one, PT, is for peat, mark and over high organic soil. Okay, when the organic matter is too high in the soil, just call it PT. Okay. Then something else is, now when you have here, before I forget, here you have PI higher than 7 and PI less than 4. You have these two. If the plasticity index is higher than 7, you have this one. In this case of inorganic soil, and you have this area, low plasticity area, high plasticity area, and low plasticity area. The low plasticity area, if the plasticity index is higher than 7, then you plot above the line A, then you have clay with low plasticity. Okay. But if now the plasticity index is less than 4, or you plot below the line A, this line A, in that case, you have silt with low plasticity, ML. Another situation that may happen is when you fall here, this area. It means in this area, the plasticity index is between 4 and 7. As you can see here, is strictly high, strictly lower, strictly higher than 7, is strictly lower than 4. So once it is 4, just 4, you have to use this double symbol. And if it is 7, you have to use also this double symbol. If it is between 4 and 7 also, you have to use this double symbol. This one, CL, ML, here, both of them. If you are in this area, okay, just remember that. So this will be the end for this second part of this classification. Technically, this is the end of this video, because this will cover everything about the classification. So just to clarify everything, to make this classification, you need to know this point. You need to know the percentage of gravel, and that percentage is the fraction passing the 76.2 millimeter sieves. And that fraction and retain on the sieve number 4. I think I have explained this at the beginning of this video. You need to know also the percentage of sand. Percentage of sand means it passes what is passing sieve number 4, but retain on sieve number 200. That interval is sand. And you need also the percentage of silt and clay, means fines. That is the percentage of soil passing the sieve number 200. And you need also this uniformity coefficient and coefficient of gradation is the curvature, coefficient of curvature. Coefficient of curvature and the uniformity coefficient. You need these two also. As you remember, we use these two for classification of coarse grained soil. And you need also liquid limit and plasticity index. This is for classification of fine-grained soil. Okay, so this is just what we need to do this classification. And the group symbol for coarse-grained soil, just a reminder, are these. These are for gravel. And you remember double symbol. Sometimes we have to use double symbol when the amount, the percentage of fine is between 5 and 12. You have to use this double symbol for gravel and for sand also. Okay, gravel. For the fine, we have this, and don't forget this double symbol in case of the liquid, the plasticity index is between 4 and 7 for the fine grained soil. So these are the symbols for fine grained soil. And recently, this American Society for Testing and Material, this designation, they created a new system to try to help people find these names. Okay, but to do that, we need same thing, the same information we needed to do the classification. This information, the percentage of fine fraction, coarse fraction, gravel fraction, and sand fraction. So this, I think there is nothing to explain here. You just read well-graded gravel if less than 50% of sand, then you say well-graded gravel. If it is 50 or higher than 50% of sand it contains, then you say well-graded gravel with sand. In that case, the amount of sand is not negligible. Okay, you can read this information as it continues from here. This is for coarse-grained soil, and this one is for gravel, sorry. And from here, sand starts. S is for sand starts. Okay, you can just read this. There is nothing to explain here, I think. Just how to read it, very simple. And here as well, that is for fine grained soil. The liquid limit less than 50, this part above, and liquid limit equal or higher than 50, this part. Okay, so just follow the arrows and you will get the names. Okay, this one is organic. These are not only organic, but these are organic with low plasticity, organic with high plasticity. Okay, same, you just follow the arrows and you will know the name. I think there is nothing to explain here. Okay, maybe too long video, but I hope you got something. Okay, thank you very much and see you next time.